Today I'm going to continue talking about data structures. I made a video about data structures and it ended up being an hour and a half long, so I broke it up into 3 pieces and this is the second piece. So if you haven't seen the first part, be sure to look in the description for a link to that, and up here I have a link, and watch that before you watch this. And in that video I talked about what data structures are. I used some familiar data structures that we use every day, such as lists and books, and related that to some data structures that computers use. So let's pick up where I left off and start talking about some of the data structures you may see if you make a formal study of data structures. And here we go. So let's move on to the next structure to talk about. And this is one you will learn about in studying data structures. It may not be the most logical place to start, but since we're already talking about disk drives, I'm going to talk about it, and that is the linked list. And what you will learn about that is that we have a piece of data that links to the next piece of data. This is how it's usually shown, a series of bubbles or squares, each with an arrow pointing to the next piece of data. And, well, does that really tell you anything useful? It wouldn't tell me anything useful if I didn't already have experience with a linked list. And that was with the Atari file system. I cut my teeth on the Atari 8-bit computer. And it had its own file system on the disk that I became intimately familiar with. I don't remember why I became so familiar with it, but I did. And so I'm going to tell how that works, and this explains how a linked list works and why we would have a linked list. So we have the same issue with the Atari system as we had with the system I just described. So I'll draw that the same way. We have a stack of bytes. Think of it like a bunch of shoe boxes or whatever you want to think of it. And we start out with the directory. There was only one directory. There was no concept of subdirectories on this disk, at least not in the early stages. So there's your directory or table of contents. And each directory would have the, here's the byte has name, letters of the names, and then a couple of bytes that would be a pointer to wherever the file was. So let's say the file is right here. And we have the same issue we had with the other file system where files could become fragmented. So in order to handle that, what we did is once again, each directory, I'm just going to show this as a number of bytes. We have a directory entry, so a number of bytes, and then a number that points to the first byte of that particular file, or that particular chapter, if you will. And then we have a number of bytes. Actually, I had 128 bytes per sector on this disk, or per block. And so we had 125 bytes of data. And then the last 3 bytes had information necessary for management. And that contained a pointer to the directory entry. In other words, here's number 1, 2, 3, 4. It would have a pointer that pointed back to that just to make sure that nothing got mangled in the process. And if it didn't match up, you got some kind of an error. It had a pointer to say whether or not this sector was full, because just like the other one, we might have a sector that has full data, then we come to the end of the file where we don't fill up the sector, just like you might not fill up the page of a book. And that would say whether or not it was full or not, and then say how many bytes were used in that sector. But then there were 10 bytes, so excuse me, 10 bits. So 1 byte plus 2 bits. Let's see if I can get this done right. 1, 2, 3, 4, 5. I mangled that. 1, 2, 3, 4, 5, 6, 7. There we go. So there's 8 bits and 2 more bits, 10 bits, which would be a pointer to the next sector in the file. And 10 bits, you can handle a number as big as 1024. So there were 1024 sectors on the disk. Each sector had 128 bytes. 125 of those bytes were the data, 3 bytes of this overhead I'm talking about. So what we had is a pointer to the block, data, 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 data. Where's the next block? So I'm going to redraw this a little bit. So I'm just going to make things a little smaller. There's my directory entries. Here's my blocks of data. So there's a sector, there's a sector, there's a sector. So each one of these is 128 bytes. It should be a capital B. 128 bytes, another sector, another sector. So here's sector, let's say that's sector 100, 101, 102. So here's an entry that says file 1, and it starts at sector 100. So we go to sector 100. Sector 100 has the data. The last 3 bytes have 10 bits that say what the next sector is. And that would be, well, sector 101. Then we do sector 101, and the last 3 bytes, somewhere in there is 10 bits that says that the next sector is 102. And let's say this is a fragmented file because we've written files and erased files and things have become a mess. And so the next is, let's say 102, 103, 4, 5. Let's say the next one is 106. And so the end of this sector would be a pointer, 10 bits that says the next sector is 106. And then just make it easy, the next one is 107. So data, pointer to the next sector. 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 And so the operating system, when it needed to go get a file, would go get the, you could specify the name, it goes and finds that file name, says, oh, starts at sector 100. Grabs sector 100, then sector 100 says, oh, the next sector is sector 101. Goes and grabs sector 101, that says the next sector is 102. Goes and grabs 102, that says next sector is 106. Jumps to 106, grabs that one. Then says the next sector is 107, grabs that, and 107 says, oh, by the way, I'm the last sector, and here's how many bytes are actually data. And then it can put that file together. So that is an actual real-world example of a linked list. Why do we need a linked list? Because the data might be scattered around. And how is it actually implemented? We have data bytes, and then other bytes. Embedded in those is a number that points to the next sector. So that's a real-world example of how a linked list works and why we would use it. And by the way, you've seen something like this in human-readable form. Ever read a magazine or a newspaper? You're reading your article and it says, continued on page 103. You go reading down and it says, continued on page 106. Go down, continued on page 109, or whatever, depending on how big it is. So magazines use this to efficiently use the space inside the magazines, newspapers too, of having parts of an article and a pointer to the next part. That's a linked list. So there is an actual implementation.